Geography 100 lecture podcast series. My name is Brian Krause and I'm your instructor. And today we're going to be discussing mass wasting, which is the process whereby weathered material is moved downslope under the direct influence of gravity. As all mini lectures, I'm not going to be discussing all topics or ideas presented in your text. Rather, my aim is to highlight a few key ideas and discuss them in a bit more detail. So on that note, let's jump. So the learning outcomes for this, which you should know at the end of this lecture, you should be able to compare and contrast the different types of mass wasting. As stated before, mass wasting, which is the process whereby weathered material is moved a relatively short distance downslope under the direct influence of gravity. So gravity is the #1 force behind mass wasting, or also referred to as erosion. It is quite common, especially in areas where there's lots of precipitation, you tend to get lots of mass wasting. So mass wasting is also referred to as mass movement. So the 6 types of mass wasting we're going to discuss here are all going to be categorized based on the velocity of movement with soil. So we're going to be talking about rockfall, landslide, slump, earth flow, mud flow, and creep. So rockfall is going to be the fastest moving of all mass wasting that we're going to discuss. Rockfalls occur when a piece of rock on a steep slope becomes dislodged and falls down the slope. And it may contain just a single rock or a mass of rocks. Because this process involves the free fall of material, falls commonly occur when there is a steep cliff. At the base of most cliffs, there's this accumulation of this fallen material that's called talus, or also called scree, which is simply just unassorted angular rocks. And here's a picture that we can see of talus being formed here at the base of the cliff, with this talus cone that's being formed right here. In this picture, we can just also see just an assortment of rock sizes that have kind of cutting down in this rock fall and is blocking the road. The next type of mass wasting is a landslide. And a landslide is this sudden, rapid movement of a cohesive mass of regolith or bedrock that is not saturated with moisture. It's key that it's not saturated with moisture. And it's an instantaneous collapse of the slope, which means it happens all at once. While some landslides might move only regolith, some can move massive rocks. Because of this, landslides can be referred to as rock avalanches or debris avalanches. And here's an example of a massive rock that is associated with this landslide type of mass movement. Note that there is not much organization to the sediment brought down in this slide. It's just kind of an assortment of stuff. Slumps can be quite sudden at times because they kind of act as a sinkhole. So a slump is a downward and outward movement of rock or unconsolidated materials moving as a unit or a series of units. So large blocks of material move suddenly downward and outward along a curved plane. So here's an example of a slump where we can see that the soil not only moves downward, but also kind of rotates outward. We can see how these kind of happens in these different little ledges of it rotating outward. And due to this down and outward movement, slumps are sometimes called rotational slides. So earth flows are the most common type of flow movements where a segment of water-saturated slope moves a limited distance downslope. And this usually occurs during or immediately after a heavy rainfall, which is going to saturate that soil. Earth flows generally occur where there is relatively little vegetation on the hillside as well. Earth flows do not involve any kind of drainage networks, therefore they occur on these open hillsides. And these flows move at a relatively slow pace, so they are less dangerous than a mud flow, for example, which we're going to talk about next. And here is a picture of an earth flow, and it's, as you can see, it's not heavily vegetated. It just has some grass on the slope, which doesn't act as a strong anchor to keep that soil from moving. It's also not in a drainage network. It's just on an open hillside where we had this earth flow movement. And also you can see it didn't move a great distance either. It kind of just oozed down the hill. Mudslides originate in a drainage basin and in arid and semi-arid regions. And they occur because the soil becomes completely saturated with water due to these torrential rains. The soil is completely locked up with moisture, so it becomes impermeable. So there's nowhere for the water to go except to act as a runoff and mixes with the soil. The more mud and water that mix, the
the more devastating the mud flow can be. The important distinction between an earth flow and a mud flow is that mud flows move along the surface of a steep of a slope and down kind of an established drainage channel, where we just talked about the earth flow didn't move down a drainage channel. Mud flows do. Mud flows tend to move more rapidly than earth flows as well, because they have more water in them. So they often pick up large rocks and other debris as part of their load. And so therefore they can be referred to as debris flows as well. So here's a mud flow in the San Juan Mountains in Colorado. You can kind of see it starts way up the mountain and kind of flows on down. And you can see it's kind of going down these kind of established drainage patterns, large drainage patterns in this case. So creep is going to be the slowest of all movements. So we went from rockfall, which is the fastest, and now here we're at creep, which is the slowest. And creep is caused by the expansion and contraction of the soil, and the most significant being the alternation between freeze, thaw, or wet, dry conditions. It's very hard to measure because it's so slow movement. It moves very, very slowly. So you want to take a look at the clues on the hillside. So if you were to look at a fence post and they're becoming horizontal to the hillside, then what's happening here is that it's being brought down slope through the process of creep. And here's another example of soil creep, where grazing animals can accentuate the soil creep through the formation of a network of hillside ridges known as terracets. A special form of creep called solidification occurs in relatively cold regions where short summers thaw the uppermost layer of the soil, but below it remains, the layer remains permanently frozen, and is called permafrost, through which the water does not drain. So you have the soil at the top that thaws, has some water, but the lower soil, the permafrost, it can't penetrate that. So the water saturates, the soil at the top becomes saturated and weak, and the upper layers then kind of flow very slowly down slope on top of this permafrost, and it creates these little distinct lobes, these little round segments that you see on there. And so it's kind of slowly creeping down the soil as well. So in your textbook, please read over the section about the La Conchita landslide. At the time of this landslide, I lived in Santa Barbara, and it was a major event. The mud flowed over the Highway 101, which is kind of the major artery between Santa Barbara and Southern California, as well as kind of Santa Barbara going Southern California up to Northern California. And it closed the highway for several days. This had a major impact on goods that couldn't be shipped to Santa Barbara and beyond. But more importantly, many people lived in just south of the landslide in Ventura, which is just south of, as I said, of La Conchita, and they worked in Santa Barbara. And most of these people then couldn't go back and forth between their home and work, causing kind of major disruption as well. And one of the interesting things that they did as a workaround until they cleared the highway was these ferries were established that you would park, people would get on these little boats, and they would take you up to Santa Barbara, then you'd have to find your way to work and so forth, and you'd take them back. So that kind of caused this little industry to form. So in any case, it was a big event, and so please read over that in the book. On that note, that ends chapter 15 on weathering and mass wasting. See you next time.